Alright, question 7. I'd like to remind you that if something's divisible by something else, there's no remainder. The remainder is 0. So for example, is 72 divisible by 9? Well, I know 72 equals 8 times 9 plus 0, therefore yes. Is 75 divisible by 4? 75 equals something times 4. Let me do it on my calculator. 75 divided by 4. It's 18 times 4 plus 3, therefore no. Plus 0 told us yes, plus 3 told us no. If remainder equals 0, it is divisible. So that was just some stuff I wanted to go through. That's not the actual question. That's just some theory to let you know what we're aiming for. So what we're going to do is we're going to, in 7a, we're actually going to divide this out. So this is our polynomial. And this is what we're going to end up dividing by. And we're going to show that it has remainder 0. And then we're going to end up being able to factorize a bit more. So don't worry, you'll see it. So we've got x to the 3 plus 2x squared, take 11, why am I writing so small? X to the 3 plus 2x squared minus 11x, take 12, and we're dividing by x, take 3. So first step, divide and write above, x squared. Second step, multiply and write below, x cubed, take 3, x squared. Third step, subtract and drag down. So, 0, 5x squared, and take 11x. Okay, start again. 5, divide and write above. 5x squared divided by x, 5x. Multiply and write below, 5x squared, take 15x. Third step, subtract and drag down. So we've got 0, positive 4x, take 12. Okay, back to the start. First step, divide, plus 4. Second step, multiply and write below, 4x, take 12. Third step, subtract and then drag down, 0, 0 can't drag down. Oh, we've got a remainder of 0. So we know that x to the 3 plus 2x squared, take 11x, take 12, actually equals x take 3, sorry, I should write what's above. X squared plus 5x plus 4 times x take 3 plus 0. So the remainder came out as 0. Therefore, it is divisible. Okay, 7, and hence express it as the product of 3 linear factors. Now, this was our polynomial we started with, yeah? This is what we divided by, and this is what we realized the quotient would be. But if I take that quotient and I factorize this again, what multiplies to give 4 and adds to give 5? X plus 4, x plus 1. So I can actually rewrite x cubed plus 2x squared take 11, x take 12 equals, well, instead of the blue I can write x plus 4, x plus 1. And then I've still got my x take 3 afterwards. So this blue became these, which actually means if I wanted, I could sketch this now. Have they asked us to? Oh, okay. Well, they haven't outright asked us to, but we're going to sketch it because To do this, the easiest way is to sketch every time. So, I can't even draw a straight line. We're not going to do a great job sketching. We're not going to find any intercepts or anything like that. Y, X. We're just going to do a fairly rough sketch. So that's going to be x plus 4 means minus 4. X plus 1 means minus 1. X take 3 means positive 3. And we know it's either going to go this way or the other way. So let's check a value down here. Oh, let's check a value down here. So that was 4. Let's check minus 5. X equals minus 5. P of x equals, well, it's minus 5 plus 4, minus 5 plus 1, minus 5, take 3. Negative times negative times negative equals negative. So we know we're going to be like that. But it would have kept going up. So, to find when it's greater than 0, so P of x is greater than 0 when, well, let's highlight the areas that has it greater than 0. And I'm going to do these in hot green, sorry. It's greater than 0 here because it's positive here, and it's greater than 0 here. So considering this was minus 4, minus 1 and positive 3, it's greater than 0 when x is greater than or equal to negative 4 but less than or equal to negative 1. So when it's between negative 4 and negative 1, and when x is greater than or equal to 3. Now, I had greater than or equal to 2 for each of these, but in the question it just said greater than. So yoink and yoink. That's question 7.